If 4 times x minus 2 is equal to 2 times x minus 4, what is the value of x? So we have 4 times x minus 2, so let me just expand that, 4x minus 8, and then on the other side it will be 2x minus 8, and then that's going to be 2x is equal to 0, and therefore x is equal to 0. 2x is equal to 9. What is the value of 2 to the power of 6x minus 23? Well, if 2x equals 9, and this has, it's really small, 6x minus 23. Let me enlarge it. That 6x we could probably get from this 2x. Just multiply both sides by 3 and you'd get 6x. And then the other side would be 3 times 9, which is 27. 3 times 9. So therefore, this 6x becomes 27, and then minus 23. And therefore, you got 2 to the power of 4. And 2 to the power of 4 is 16. Determine the coordinates of the point of intersection of the lines with the equations y equals 3x plus 7 and y is equal to 7x plus 3. Okay, well, since they're both equal to y, you set them equal to each other. And therefore, you'd have 3x plus 7 is equal to 7x plus 3. And then you just do this basic algebra. 4x is equal to 4, x is equal to 1. So we got the x coordinate. Plug this x equals 1 into either of these, and when you do, you'll get, I believe, 10 for the value of y. So therefore, the point of intersection xy would be 1 and 10. There is one positive integer k for which 3 is less than the square root of k squared plus 4 is less than 4. What is this integer, k? Okay. So we have 3 is less than the square root of k squared plus 4 is less than 4. Okay, so let's square everything. So this becomes 9. The square root therefore disappears, and then this becomes 16. Subtract 4 from everything, and we get 5 is equal to k squared is less than 12. So we have to figure out some positive integer that when squared will be between 5 and 9. And by inspection, I can tell you that it is 3, because k squared would be 9, and 9 is indeed between 5 and 12. Let's see if I can squeeze this in here. Perhaps I can. Part B, this one. What is the sum of the smallest 20 smallest... Well, let's start over again. What is the sum of the 20 smallest odd positive integers? Okay. All right, so the smallest ones are 1, 3, 5, 7, and so on, right? And we're 20 of them. So the 20th one, I guess, would be, let's just keep going here. 33, 35, 37, 39, I believe, is the 20th one. Yeah. Okay, so then they want us to figure this out as a sum. Okay. Well, if I have 1 and 39, that's 40. If I have 3 and 37, that's 40. And so on. 5 and 35 is 40, and you guys get the point. So how many of those pairs are there? Well, there was 20 numbers, so that means there's 10 pairs. So in each pair, it has a value of 40. So therefore, the sum would be 10 times 40, which is 400. And we have part C. In the diagram, BDF is equilateral with FAB, BCD, and DEF all being 90 degrees. AB is 16, BC is 8, DE is 5, FA is 13. Determine the perimeter of the hexagon A, B, C, D, E, F. Okay, so some of this we already have. So the perimeter is going to be 16. That's already given. 8. And then CD, I guess we have to figure out. Then we have 5. And then FE we have to figure out. And 13. Okay. So, as I said, some of that we already have. We just have to concentrate, I guess, on getting CD and FE. So the first thing I'm going to do is concentrate on this triangle right here, this guy. And with that, we get 16 squared plus 13 squared is equal to BF squared. And you can easily figure out that BF is equal to the root of 425. So since that's equilateral, that means this is also the root of 425, and this is also the root of 425. This BD side, this side right here. Okay, that allows us to figure out CD. So we have 425, the root of that squared is equal to 8 squared plus CD squared. And when we figure this out, we get CD is equal to 19. So that takes care of this guy right here. And now we just need FE, and we can solve. So FE, that very similarly, FE squared plus 5 squared would be 425 root all squared. And when you do that, you'll get FE is equal to 20. So going back to this will be 16 plus 8 plus CD, which is 19, plus 5 plus FE, which is 20, plus 13. And when you do that whole sum, you get 81. Suppose that PQR, the sum is 18, P plus Q is 5, Q plus R is 9. What is the value of Q? Okay, so P plus Q plus R is 18, and then P plus Q is 5, and Q plus R is 9. Okay, so using this, we can substitute this guy. So that's going to be 5 plus R is 18, and therefore R is 13. Correct? All right. And then using this, we substitute that in the original one, and we get P plus 9 is equal to 18, and therefore P is equal to 9. So therefore, what did they want us to figure out? Oh, the value of Q. So plug the value of P and R back into the original equation, so that's going to give me 9 plus Q plus 13 is equal to 18. So Q is equal to, what is that, 22, 18 minus 22, and that is negative 4. The line with equation 6x plus y equals 24 has its x-intercept at point P and its y-intercept at point Q. What is an equation of the parabola whose y-intercept is at Q and whose only x-intercept is at P? So let's draw this. Let's see what we have here. So x-axis, y-axis, and well, let's see here. 6x plus y is equal to 24. So its x-intercept is when you set y to 0. So that's going to be 6x is equal to 24. Therefore, x is equal to 4. So 4, 0, wherever that is, let's say that's 4, 0, is point P. 4, 0. Y-intercept is at point Q, and that's the y-intercept of this guy. So that's when you set x equal to 0. So that just means y is equal to 24. So it's way up here, 24. And this point, 0, 24, is Q. Okay, so we have a parabola, so I'm not sure how this looks exactly, but I'm just going to make a, oh boy, not a very nice diagram, but it's actually not so bad. That's actually pretty decent. Okay, so that's the parabola. This is the parabola that they want. So now what do we have to do? We have to figure out the equation now. So the equation of a parabola is of the form ax minus h squared plus k. Okay, now what do I, oh boy, that's a lot of variables. X is not the variable. A, h, and k, a lot of variables here. I need three equations because I have 3 variables. I can get one equation with this guy, one equation with this guy. Where do I get the third equation from? I think I can just use the fact that parabolas have the symmetry, right? If I can even draw that as a straight line. What is on one side is the exact same. So if we draw a line from there to there, this point right here would be symmetrical. So that would be, let me see here, it would be 8 for the x coordinate and then 24 for the y coordinate. So that definitely is going to help us. Okay, now I have 3 points, and therefore I can create 3 equations, and it just becomes a big, long algebra problem. All right, so let's do it. So where do I start here? Let's start with this guy first, 0, 24, using that as my standard. So when x is 0, 24 is equal to x is 0, right? So ah squared plus k. Okay, and then let's try this one here. So that's going to give me 0 is equal to a times 4 minus h all squared plus k. And then this guy, that is going to be Oh, hold on here. What am I doing? Yeah, that one is going to be y is 24 is equal to a times h minus 8 squared plus k. Okay. All right. Well, then I guess I have to expand all this. Oh boy. Okay, so let's expand all this. So 24 is equal to a times, what's that, 64 minus 16h plus h squared is plus k. And then 24 is equal to 64a minus 16ah plus ah squared plus k. And then let's see here, where do I go from here? Well, this guy right here, ah squared plus k, is that. So that's 24. That's very helpful. So that's just 24. And therefore, let's move this up just a little bit. The 24's cancel, so I just get 64 is equal to... Sorry, I missed an a there. 64a is equal to 16ah. The a's cancel. 16h is equal to 64. And therefore, h is equal to 4. Okay, that's one finding. Still have to find the k and the a, but that shouldn't be a problem. Okay, so now let's go back and substitute that somewhere, actually. So that's going to be 24 is equal to... Where am I substituting this? H is 4, right? Okay, I guess I substituted into these guys here. Those two. So 24 is equal to 16a plus k from the first one, this guy. And then from the second one, it would be 0 is equal to a times 4 minus h all squared plus k. Okay. So, therefore, well, hold on. 4 minus h. Well, h is 4. So, I guess I can put that in. This is 4. Yeah. Yeah, is that right? Yeah. So, therefore, from this one, we just get k equals 0. Okay, that's very helpful. And then plug that back into here. We get 24 is equal to 16a. And then finally, a is equal to 24 over 16, which in lowest terms would be 3 over 2. Okay, finally we got it all. So therefore, the y is equal to 3 over 2 times x minus 4 all squared. And then the k is 0, so we don't need to put that in. So y is equal to 3 over 2 times x minus 4 all squared is the equation of the parabola. Suppose that 1 over 2w is equal to 1 over 3y is equal to 1 over 4z, and 1 over 2w plus 1 over 3y plus 1 over 4z is equal to 1 over 24. Okay, determine the value of w plus y plus z. All right, so let's start with this one. And 1 over 2w plus 1 over 3y. Well, 1 over 3y is equal to 1 over 2w, so I had to make that substitution. Similarly, 1 over 4z is equal to 1 over 2w, so make that substitution. And then we have 1 over 24. So this one is 3 over 2w is equal to 1 over 24, and if you cross multiply, you'll get 72 is equal to 2w. Therefore, w is 36. So I think in a very similar way, you would do the other ones. So just take that equation and make the substitutions. So this time for 1 over 3y, that's 1 over 2w is equal to 1 over 3y. And then 1 over 3y, and then 1 over 4z is also equal to 1 over 3y, and that is equal to 1 over 24. So this time, again, 3 over 3y is equal to 1 over 24, and therefore 72 is equal to 3y, and therefore y is equal to 24. And then finally, the z guy, 1 over 2w is equal to 1 over 4z, 1 over 3y is also equal to 1 over 4z, and then you have the 1 over 4z is equal to 1 over 24. So this is 3 over 4z is equal to 1 over 24. 72 is equal to 4z, and therefore z this time would be 18. And then finally, they want this, w plus x plus y. So w is 36, y is 24. and z is 18. So 36 plus 24 plus 18 is 78. Terry's bicycle has a larger front wheel with a radius of 15 and a smaller rear wheel with a radius of 9, as shown. Terry ties a ribbon to the top of each wheel and then starts to ride forward. Terry travels d centimeters forward and stops. Both ribbons are again at the top of the wheels. What is the integer closest to the smallest possible value of d with d greater than 0? What happens is this ribbon right here is going to go around one time and then end up where it is. And then same thing, that ribbon will go around one time, one revolution, and end up where it is. Now they're saying, when do both ribbons end up back at that top? Okay, to do that, we have to figure out sort of a calculation of the diameter and circumference. So circumference is given as pi times diameter, right? And circumference is also as 2 times the radius. Now in this case, the radius, I believe, is 15. So this is going to be pi times 2 times 15. So the circumference is 30 pi. So that means every time that front wheel travels 30 pi in the distance, it will result in that ribbon coming right back to the top again. So when the distance is 30 pi, 60 pi, 90 pi, 120 pi, and so on, you guys get the point. At all of whenever that front wheel travels this as a distance, that ribbon will be at that top position again. That's for the front wheel, the big one. Now the small wheel is pretty much this exact same, pi d, but the different d, so I guess we should put d1, d2 if you really wanted to. So same thing, I mean, this is going to obviously be c2, just to ensure that you know it's not the exact same. So c2, that's going to be pi times 2, but this time the radius is 9. So that means this is 18 pi. So by the same principle, on the smaller wheel, every time it travels 18 pi as a distance, as a horizontal distance, that ribbon will end up at the top position. So at 18 pi, at multiples of 18 pi, so 36 pi, 54 pi, and so on, 72 pi, 90 pi, 108 pi, and so on, dot, dot, dot. So what we have to do is figure out when does this distance and this distance match? When is the first time? Because they want the smallest, right? Let me see here. I think the word smallest was used somewhere here. What is the integer closest to that? Smallest possible value. So there's many. This will happen again and again, but they want the smallest. The first time it happens, I guess. And if you look at these numbers already, just the short list that I made, the first time it happens is 90. That is when the numbers are the same. So at 90 pi, this guy, that ribbon, and that ribbon will both end up at the top again for the first time. And then, of course, it'll happen again and again. But they want the smallest. So therefore, that distance is 90 pi, and they want an actual integer value, well, 90 times 3.14. And the integer closest to that number is 283. In the diagram, ABCD is a rectangle, and AB is 24, AD is 18. E is on BC, and EC is 6. If segments DE and AC intersect at F, determine the length of CF. So what I'm going to do is I'm going to put this on a coordinate scale. So this is X, this is Y, and hopefully this will make a little bit of sense as I move along. So let's label this first. 0, 18 is the coordinates for A. Obviously D is the origin, the way I've drawn it. B would be, I don't know if we need B, but it would be 24, 18, I believe. And then C is 24, 0. E, Well, we're going up by 6. They told me that. So that's going to be 24/6, I believe. Yeah. And then what are we trying to find here? The length of CF. Okay, so I have the coordinates for C. I would need the coordinates for F. Okay. I think I understand. Okay, so I need the coordinates for F. So therefore I have to find the equations of the line DE, and the line, I guess, CA. And then I would be able to figure out the coordinates for F. F would be the intersection. And then I can figure out the length of CF. Okay, so those are the steps. So let's take this one step at a time. So what are we doing first here? I guess we can figure out whatever. It doesn't really matter. Let's do line DE first. So the slope is rise over run. So that's going to be 6 minus 0, 24 minus 0. So that looks to me like a quarter. So that's going to be y is equal to mx plus b. So y is equal to a quarter x plus b. And let's substitute some formula, some point into this. Let's just put in 0, 0. When you put 0, 0, you get b equal to 0. So therefore, line DE is fairly quickly solved as y is equal to a quarter x. And now let's go back and figure out the line CA. So CA, that line, rise over run. So 0 minus 18, this is the slope, by the way. 0 minus 18, and then 24 minus 0. So that's 3 over 4? Minus 3 over 4, actually. So y is equal to minus 3 over 4x plus this b, and then substitute in one of those. So whatever you want to do, put in 0, 18. When x is 0, this is 18, so that means b is equal to 18. So therefore that equation is y is equal to minus 3 over 4x plus 18. Okay, so then finding the intersection should be easy. 1 quarter x is equal to minus 3 over 4x plus 18. That's going to be 4 over 4x is equal to 18. Therefore, x is 18. Let me just double check if I did this correctly. I think I did. Okay, so then substitute it back into either one of these equations to get the value of y. So y would be 18 over 4, which is 9 over 2. Okay, which is 4.5. Okay, now the final step is to figure out CA. See, F, therefore, would be, what's F? 18, 9 over 2. So then the final step, which is figuring out FC, or CF, that would be, let me see here, this side is 6, correct? Because we're going up by 6. Hold on, let me just double check here. You gotta make sure I do this correctly. Yeah. And then since the x coordinate of F is 18, hold on, whoa. Let me backtrack here. F is 18 and 9 over 2, correct? So 18 is this point, and then this point here is 24, so this is 6 right there. Let me draw that triangle here, because the diagram's getting a little messy. So this is 18 and this is 24, so this is 6 in terms of its length, and then that's the horizontal length, and then the vertical length of CF, that triangle at least, is what? It would be the y coordinate of F, which is 9 over 2, which is 4.5. Okay, gotta make sure I do that right. Now CF is a simple Pythagorean relationship, 6 squared plus 4.5 squared. And that looks like 36 plus 20.25. And that is 56.25. And therefore CF would be the square root of 56.25. And that is 7.5.